He just told us here, if we're on the x-axis, we're where y equals what, Shane? Yes, that's absolutely right. So these intercepts work the same. Give me the coordinates for your y-intercept here, Shane. The coordinates, both of them, the x and the y coordinate. Okay, we're talking about the y-intercept now, Shane. X is going to be what? Raise your hand if you want to help Shane out. Go ahead, Jay. 0, 20. 0, 20. X is 0 if we're on the y-axis, and y is 20. So that's our y-intercept, 0, 20. Shane, what would the x-intercept be? Good. That's going to be 5, 0. X is 5. And since we are on the x-axis, we are right where y equals 0. X is 5 and y is 0. That's good. All right, so that answers A, Shane. Find and interpret the slope of this line. Shane, what did you get for your slope? Well, how did you do your slopes? First of all, what is my equation for slope, Shane? Say that louder for me.
M equals y over x.
Good. M equals y over x. So M is my slope, and it's equal to y over x. What words did we use for y, Shane? What word did we use? Right. X, Corey. Run. So rise over run. Okay, what numbers do you want to put in here? 20 over 5. Good. 20 over 5. Okay, Ronisha, what is this called? We do have it in slope form, but what kind of slope? This slope is what? Okay, this is a negative slope. Okay. As far as the form that it's in, what form is it in? Raise your hand. Go ahead, Shane. Okay, this is an improper fraction. Can we leave this way? No. Okay. Markel, do you have any common factors in this improper fraction before we start? We're going to have to convert it to a what? A mixed number. But before we do that, can we reduce it? Yes, we can. Braden, what's the greatest common factor? 5. Good. Greatest common factor is 5. All right, 20 divided by 5 would be 4. And 5 divided by 5, 1. So, Shane, your slope is what? 4 over 1, or just what, Ronisha? 4. 4, that's good, okay? Find an equation for this line. Shane, you have a x and a y-intercept, and you also have the slope. Okay, you have x and y-intercept, but you also have the slope. Shane, what equation do you think we can use here to solve, at least what equation can we use for this line? Good. You want to use slope-intercept form. You want to use slope-intercept form. And let's write that on the board here so everyone can actually see it. There we go. Y is equal to mx plus b. And let's see here. Kendall, can you tell me what b is? Get someone to raise a hand and help her out here. Go ahead. Okay. It's your y. Okay. Now you have your homework. Let's get that out for me. So we have a slope. Okay, Shane, what's my 4? So y is going to be equal to 4x plus. What was my y-intercept, Shane? 20. 20. So there is my equation for this line. Now, if Pryor buys 3 comic books, how much money will she have remaining? Shane, what are we going to do with that number 3?
Will we put in like the X?
There you go. Good, because our graph up here tells us, the statement tells me that X represents the number of comic books. So good, we'll put it in for X. Thank you. We'll put it in for X. So now we have a definite value for our variable X. Y is going to be equal to 4. What operation are you doing with the 4 and the X, Shane? Multiplying, good. Times 3.
Teachers, at this time, the testing site is now available. The testing location is now available. Thank you.
Okay, so we just substituted the 3, which represents the number of comic books, in for X. Shane, you said that we're multiplying here, so 4 times 3 gives me 12 plus 20. So Y is equal to 12 plus 20. So how much money will we have remaining? $32. Good. $32. All right, so did they clear it up for you, Shane? Okay, good. All right, anybody else have any questions over this before we move on to today's lesson? Go ahead, Bray.
If she starts at $20, how does she do that by buying 3 comic books?
How does she do what now?
If she's buying 3, how does she have 32?
Yep. So what happened here? What happened up here? Huh? You forgot to do what? Okay, because you said something earlier about the. It's negative. It's negative. It's negative. Okay? It's negative. This is actually going. Negative. So that's where the mistake was made. Here you go. You're going down. Good. So your should actually be what? You got to pay attention to that. Negative 4. It should be negative 4. Good, Braden. Negative 12 plus 20 is 8. There you go. That's one of the things that you haven't dealt with. It said not slopes are positive, right? Well, not all. Good catch. Thank you. All right. Did you have a question over another problem? Which one? Number 3? Okay, good. Great. Okay, match each equation with its 3 solutions, Here, the only thing we have to do is, what are we really doing here? Somebody raise your hand and tell me what we're really doing. Okay, what value is this? X and all of these have X and Y. So what are we really doing with those values? Plugging them in. Thank you, Jonathan. That's exactly right. We're going to be plugging these in to see if, in fact, they work with either one of these equations. So in A, somebody raise your hand and tell me, what did you select as the match? Which 3 solutions match equation A? Which 3 match equation A? Go ahead, Ronisha. Number 1. So you said A and number 1 actually match. Okay, so if X is 14, 14 is being multiplied by 1 5/10. 14 is being multiplied by 1 5/10. Let's get everybody to get your paper out. Go ahead and Let me see you work that out for me. 14 times 1 and 5/10, please. 14 times 1 and 5/10. About 2 minutes here. Okay, let's start with this and let's look at these numbers. One thing I want us to practice is we want to practice not using calculators. We've had quite a few bell ringers that said that they did not want you to use calculators. So 14 is being multiplied by 1 and 5/10. What is 5/10 as a fraction? Okay, 5/10 just as a fraction, it is what?
3 times?
No, just the 5/10 is 1/2. It's just half. The whole number would be 1 and 1/2 if we change this to a mixed number. What is half of 14? 7. 1 times 14 is, and 14 plus 7 will give me what? 21. So the first set of coordinates actually work. Let's look at the second set. 2 times 1 and 5/10 is 3. So that works. And 8 times 1 and 5/10. 5/10 is still half of the fraction 1/2, right? So half of 8 is 4, and 1 times 8 is 8. So 8 plus 4 is 12. So that's correct.
If you have students that you know that go and test every week, please allow them to go. We are shorthanded in the office, and so we're not going to have anyone to take them. So if you have a kinder and you have a para or a grandmother, please let them take them to the auditorium.
Okay, so that's good. So yes, 1 goes with 8. B, did anybody have which set of number goes with B? Raise your hand for me. Go ahead, Ronisha. 4. 4. Okay. So if x is 1, 1 times 2 is 2. Okay, so you have to just write down this on the board clearly. Our equation is 2x plus 3y is equal to 7. We're dealing with 1 and 2. 1 and 1 2/3. We're going to substitute the 1 for x. Two times 1, 2. Okay.
Ms. Broadway, report to Ms. Watley's room. Ms. Broadway, report to Ms. Watley's room.
Let's see here. Julia, what are we trying to isolate in this? We're trying to isolate in this third step. We're trying to isolate. Say it a little louder for me. Y, yes. Okay, we're trying to isolate Y. Braden Thomas, what do we have to do in order to isolate Y? What method do we have to use? We had it up on the board earlier this week, and I was telling you it was something a certain order that we used, and because we are working an equation or trying to find a missed value, and we're not trying to find a single number that this is equal to, that we use this order, but we have to use it in the reverse order that you were taught. So we're going to be using the order of what? Go ahead, Jonathan. Okay, there you go. We're going to use the order of operations. We're going to use the order of operations. Okay, but we are going to be using it in what order again? In the reverse order. Good. So what should we do first here? If we are doing this in reverse order, this tells us to start with addition and subtraction, right? So what do we need to, do we have anything here that we need to add or subtract to help isolate y? What do we need to do with this? What do you say we need to do, Bray? Okay, right now, what are we doing with the 2? Right now, what are we doing with the 2? Are we adding the 2, or is the 2 positive or negative? Look at it that way. Okay, so if we want that 2 to be away from this side, or we want 0 2s or no whole numbers over here, what should we do with the 2?
Subtract.
Okay, what did you say, Anai? Okay, we need to subtract the 2. Look at what we're doing. Addition, subtraction. This 2 is positive. So if we want it to be 0, we're going to have to subtract it. We're going to subtract the 2. If I need to do. So we're going to subtract it from the right also. So my fourth step, 2 minus 2 is this down, and we're left with 3y is equal to 7 minus 2 is 5. 7 minus 2. Now, we do addition and subtraction. The next step, if we're going in reverse order, is multiplying. Operation is multiplication. So, now what do I need to do in order to isolate this y? Both sides by 3. Good. All right, 3y divided by 3 leaves us with just what? 1y. Good, a single y. We're going to know what y is actually equal to. And 5 divided by 3. 5 divided by 3 will give us 5/3. But Jaden, what kind of fraction is that? Can I leave this that way? No. Okay, so what operation do I need to do in order to convert this? What operation do I need to do in order to convert this? Somebody raise your hand and help Jay. Now, go ahead, Markel. Okay, we need to divide. A fraction is a what type of problem? Division. So that's what we're going to do. We're going to divide this. What type of fraction is it again? Improper. We're going to divide an improper fraction. So, which number is actually going to be divided? The 5 is being divided by 3. How many times can 3 be divided into 5? 5 minus 3, 2. So what is my whole number for my improper fraction? I'm sorry, for my mixed number. 1. My denominator is 3. And my numerator, 2. Okay, so 1 2/3. So Shane, do you see how we're actually doing this? We just have to plug the numbers in. That's what you're going to be doing the whole time, okay? You're plugging the numbers in. Does anybody else have any questions over the home? Remember, you're just plugging in an x value, and then you're going to isolate and solve for which one? Which value should you be solving for if you plug in, John? Y. Good. Good. Okay. Got some more over here. About a minute and 30 seconds. A minute and 30 seconds. So did you make X 1? Okay. So if you're isolating Y, what do you need to do? What operation are you doing with 7 and Y now? Okay, so what's the opposite of that? So you need to divide this by, you're trying to isolate Y. See? There you go. There you go. There you go. Okay, let's take a look at this. Let's take a look at this. And what I'm going to do is I'm going to plug in a couple numbers myself and just go through and show you how I would actually do this. Let's do this on the whiteboard so we have a little more space here. Okay, looking at this, number one, 6x is equal to 7y. 6x is equal to 7y. What operation are we doing on the left side of the equal sign here? Somebody please raise your hand and tell me, what operation are we doing on the left side of the equal sign? Go ahead, Anaya. Multiplying. What operation are we doing on the right side of the equal sign? Ronisha, still multiplying. Okay, for the sake of simplicity, I'm going to use 1 for x. I'm going to say that x is equal to 1. Okay, so if x is equal to 1, I should have that 6 is equal to 7y. That leaves me with the task of isolating what? What do I need to isolate now? Y. I need to find out what y is equal to. What operation are we doing with the 7y? Okay, so in order to isolate the y, we need to do what, Braden? We need to divide. Good. We're going to divide both sides by 7. 7 divided by 7 is 1y. Y should be equal to 6 sevenths, okay? 6 sevenths. In number 2, what operations are we doing in number 2? Somebody raise your hand. Markel, what do you see us doing? We're multiplying 5x and a 3y that, and you good, and we're adding. So give X, Markel? What value do you want to give X? It could be any number. 2? Okay, X is equal to 2. So we have here 5 times 2 plus 3y is equal to 9 after we substitute our 2 in for X. 5 times 2 is 10 plus 3y is equal to 9. We're trying to isolate what, Markel? Trying to isolate the y. So what do we need to do, Markel? What should be my first step in isolating this y? Okay, look at your order of operations. What should be your first step? You're going backwards. Okay. Okay, and what are we going to subtract? Okay, subtraction is right. We're going to subtract first. But what do we need to subtract first, Camilla? What do we need to subtract here in order to isolate y? Shane? Okay, we have to subtract the 10 from both sides. That's the only number that can be subtracted. It's a single number. It's not being, there's no other operation involved with 10 right now, Camilla. You see, it doesn't have a letter written beside it, so it's not being multiplied. It's not being divided. So the only thing you would be doing is adding 10 to whatever 3 times y is. So that would be my first step, is to subtract the 10 from both sides. 10 minus 10, 0. So we're left with 3y on the left equals 9 minus, good, negative 1. So we're still trying to isolate y. What operation are we doing with 3 and y, Corey? What operation is that, 3 written beside y? Good, multiplying. So in order to get the 3 away from the y, what do we need to do? Good, we need to do the divide. 3. Divide both sides by 3. 3 by y, 1y, 1y. Will be equal to negative 1/3. Negative 1/3. Okay? So that's about the extent of the bell ringer. You see how many steps there are and things like that. So just remember that. Remember, we have to use the order of operations still. You're just using it in a reverse order because you're solving for a variable. You're solving a problem that's already solved, really. It's already been simplified down to one number. So we're actually going in reverse order. So you're trying to solve for a variable. Let's take a look at our first exercise here on 13.2. True or false? Solutions in a coordinate plane. Remember, we're still trying to find solutions to these linear equations. Here, they tell us here are graphs representing 3 linear equations. These relationships could also be represented with equations. 3 linear relationships. I'm sorry. Here are graphs representing 3 linear relationships. These relationships could also be represented with equations. For each statement below, decide if it is true or false and explain your reasoning. Now, we're going to do these. You're going to tell if it's true or false, explain your reason. But during this time that we're doing this stuff, if you have any questions, raise your hand because I'm going to be calling you up to the board to actually explain this stuff to the rest of the class. We have from page 261 to the top of page 262, there are 8 problems. There are 8 problems. I'm going to give you, let's say, 2 minutes per problem, so 16 minutes. 16 minutes. 2 minutes per problem. So let's go ahead and, in those 2 minutes per well, we'll just take 12 minutes here because we're running behind on time here. So we're going to take 12 minutes, okay? Go ahead and start now. Let's see something real quick. Better look at this one again. Look at that. Look at what your coordinates are. X is what? Yeah, you want to check that out. There you go. You have a pencil, Julie? Go. Sit up, Camilla. Excuse me, buddy. Good, okay, good. Good. Okay. If you have any questions, just raise your hand. Just raise your hand. As you can see, most of these are true-false questions, so you're just analyzing the graphs. Yep. I want to take a look at this, though. Look at the coordinates of point G. And think about why, though, Mark, here. Think about what coordinates mean. Okay, go ahead. Right. On which one? Okay, x equals 0 is the solution for the equation of line M. M. Okay, cool. The coordinates of the point G make both equations for line M and the equation for N true. Look at this. M. Is it on M? Is it on N? Okay, so what do you think that is? There you go. Good. That's all. So, there's no solution for the equation for line L. And what did they say about L, Kimmy? That has y equals 0. Go back to it. Does y actually equal 0 on line L? At any point? Okay, cool. There you go. Yeah. Good. That's wrong. Which one you on? There are exactly two solutions of the equation for line L. Go to line L. Let me see here. Look at that. So what do you say? Is that true or false? Okay, let me ask you a question. Is this going through, what would x be if you're on the y-axis? X is equal to what if you're on the y-axis, Camille? X is equal to, look over here. Look over here. This is the y-axis, okay? We're going to pretend this is x. On the y-axis, x is equal to what? Say it loud. Yep. What now?
I said, are we supposed to go to another different chapter?
No, don't worry about that. Yeah, we're going to do this together. You're just going to come up here one at a time and point out the stuff. That's all. See how much time you got there. Got about 2 minutes. Got about 2 minutes. Is there anybody that hadn't at least made it to number 6 yet? Okay, let's go. Look at this. There is no solution for the equation for line L that has y is 0. For line L that has y is equal to 0, is that true or false? There you go. Good. Good. Go ahead. Let's see. The coordinates of point H are solutions to the equation for line L. Point H, is that a solution for this line? Look at it. Now, when it's a solution, that means that it's what? The solution means that it'll give us coordinates that fall on the line. So is this a solution? Yeah. Yep. Yep, it actually falls on the line. Okay. All right, that's our time. All right, let me get a volunteer to come up here and do number 1 for us. You're going to just bring your book up so you can actually read, with the statement and show us how you concluded whether that particular statement was true or false. You really don't even need to bring the book. Markel, go ahead, come on up here for us and let's do number 1. All right, read the statement for us, please, Markel. Okay, 4-0 is the solution for line M. Okay, so is that one true or false? Good, that one is false. 0-4 is a solution, but 4-0 is not. Okay, good. Number 2, please. Let's see here. Number 2, Bernicia. Put your mask up over your nose, bro. Put your mask up. Go ahead. Okay. Okay. Good. They both meet at that point. So, yes, it is true. It is true. Good. Number 3, x is equal to 0 is a solution of the equation for line N. Go up there and show us that, please, Jonathan. Let's see if that's a solution for line N. So where is x equal to 0? Does that fall on line N? Okay, so is it true or false? True, good, good. All right, Kendall, do number 4 for me, please. 4. Okay, good. Coordinates 2-0 don't fall on any of the lines, so good. So that is false. Good. Let me get Jaden up here for number 5, please. Jaden, number 5, please. Go up your nose, Camille. Okay, there is no solution for the equation for line L that has y equals 0. So yes, that is true because L does not go through the what? Good. It does not go through the origin. Good. Thank you. So that is true. All right, let's move this up so we can these last few problems here. Anaya, could you come and do the next one, please? Number 6. Number 6. Good. So it's on the line, so it is a solution. Good, thank you. Now, let's see here. Shane, let me get you to do 7 for me, please. There are exactly 2 solutions of the equation for line L. For, okay. Does anybody disagree with Shane? Anybody disagree? Let me ask you a question, Shane. Could we say that line L is going through where y is equal to -2? Okay. So couldn't we say that x there is what? What's the value for x if you're on the y-axis? Remember from this morning, it's what? 0. So that coordinates would be 0, 0, -2. So there you go. So it's more than 2. It's more than 2. That's good. So that one is actually true or false, Shane? False. Great. Great. And the last one, let's get, let's see here. Let's see here. Corey, is there any point whose coordinates make all the equations of all 3 lines true? Is there any point that make all 3 lines true? No, that's right. That's false. That's false. These 3 lines actually make a triangle here. So that means that we know that they couldn't all go through one point. If they went through the center, if we would have raised this up to where y is equal to, it looks like it's a little less than 2, then that would be true. But right now, no. There are only 2 lines at a time that have a single solution at any one time. So, great. Now, this next activity called I'll Take an X, we're going to take, we only need about 8 minutes on this. You're going to have 6 cards. Let me get the cards for you. Now, I want you to do this in groups of 2. I'm going to do this in groups of 2. Okay, so you 2 are going to be partners. You 2, Braden, you're going to be partners with Kendall. One of you is going to have the coordinates, which will be the solutions for the equations, and the other person is going to have the equations. That's how we're going to do this. One person is going to have the solutions, and the other person is going to have the equations. So, let's see here. You take the equations. Jonathan, here's the solutions. You take the solutions to the equations. And if you would, we're going to read these directions together. Y'all 2 going to work together. Solution, equation, solution, equation. And we do have one more set. Solutions, and here you go, Mark, the equation. Now, let's check out the directions for this. The way this is going to work is one partner has cards, one partner has 6 cards, labeled A through F, just cut those out for me, labeled A through F, and one partner has 6 cards, labeled lowercase A through F. In each pair of cards, for example, cards capital A and lowercase a, there's an equation on one card in a coordinate pair, x and y, that makes the equation true on the other card. The partner with the equation has to partner with the solutions for either the X or the Y value. You only need one of them, right? Because same as up here. Look, when we substituted for X, we then ended up having an equation that only had one variable. So can you solve an equation that has one variable? Yes, you can. Can you solve a single equation that has two variables, though? No. So you only need one of these, and it will give you an equation with one variable, okay? So you're going to ask for either the X or the Y value, and then you're going to tell your partner why you chose to ask for that particular value. The partner with the equation uses this value to find the other value, explaining each step as they go. So, as you can see here, you see how I've numbered my steps? Kind of keep this stuff in order, just in case we make a mistake somewhere. Because remember this morning, one of these equations, one of these things I didn't tell you. We had a negative slope, and we ended up having a problem that didn't make sense. We had a problem where we were spending money, and because we did not use a negative slope, at the end, we ended up having more money in our pocket than we initially had, so it made no sense, right? But we did keep the equation, and we had all the steps up, and we were able to go back and figure out, oh, okay, hey, this is a negative slope, so it should have been a -4 instead of a +4. So please, whatever you do, keep your stuff neat, keep it in order. Number 3, the partner with the coordinate pair then tells the partner with the equation if they are right or wrong. If they are wrong, both partners should look through the steps to find and correct any errors, like we did this morning. If they are right, both partners move on to the next set of cards. Keep playing until you have finished cards A through F. Remember, with the equation, give the X or the Y value to start from. So, does everybody understand the directions? Okay. Now, these are going to move pretty quick. You should have a total of 6 cards. So, I'm going to give you 12 minutes. You'll have 2 minutes per card. Okay? 2 minutes per card. Everybody ready? All right, let's start now. Go ahead and start now. Ma'am. You got what? Hold on. You shouldn't be mixed up. Yeah, you shouldn't. You should only have. These are all. Okay, well, well, you should only have equations. There you go. Those are all equations. Hold on, one of them is not, though. That one's not an equation.
This is an equation.
There you go.
But that's a lowercase and the rest of them are uppercase.
I don't know how that happened, but don't worry about it. Excuse me. No. Just keep all the lowercase and uppercase. If you come into contact with a card that's an equation, start off with A. Everybody look up here. Start off with A. If you have A that is an equation, you're going to ask your partner, hey, what is the Y value? Okay? Your reason for wanting the Y value is because you have an equation, right? There you go. So you don't need to mix the cards up. I'm sorry. So keep all the capital letters together and all the lowercase letters. And as you come into contact with each one of them, you have to make a decision then whether you're going to be asking for a single value, X or Y, or whether you're going to be given a value. Simple as that. Okay, so when we look here, you're the one doing that question asking now. So don't show them your cards. Okay. Yes, ma'am. Okay. You all are starting with A, okay? Since you have the equation, ask him for either the X or the Y value, whichever one you want. Okay, what's the Y value? Okay, so now you're going to do just what I did here. Your equation, you should plug in 7 here, and then you should be solving for X. Okay? All right.
So like, I asked what's Y do.
If you're having trouble solving for the variable you're trying to isolate, just raise your hand. If you're having trouble, raise your hand. What's going on? Okay, so you have the equation, so you need to ask him. Yeah, go ahead. Ask him for one of the values.
I just actually Y.
Okay, did he tell you what Y was? What did he say Y is? Huh?
7.
Okay, so you need to plug that in. Take that Y out of there. If you know what Y is, you can erase it. There you go. Good. So now, look at the order of operations. Look at this. What do you need to do to move this to that side? Right now, you're doing what with the 7? Okay, so what's the opposite of it? Huh? So you need to add. There you go. You need to add it to both sides. That's the first step.
I'm trying to figure out the answer too.
Who?
I'm trying to figure out A. When I put the S in correct,
Which one did you ask her for?
I'm trying to figure out too. A. She has to.
She has to solve the problem.
I'm just trying to solve it. You know?
Okay, so which?
She asked for Y.
Okay, so what is Y?
7.
Okay, so what are you trying to do? Solve it yourself? Okay, this needs to be 2x minus 7 equals 14.
Yeah, this is what I have right here.
That's not 7.
7 Y.
No, it's not 7y. It's 7. Y is 7. All right, give me 5. Listen up. Hey, look up here. Do you see how the x went away? X is 2. So the x doesn't remain. I see some of you leaving these letters in here. If you're asking for the value of y, and they tell you that y is equal to 8, the 8 takes the place of the y, because that's what it's equal to, okay? But you're confusing yourself, leaving the variables in here. Okay, so you know, once you know the value for that variable, you don't leave it in. Okay, let me see what you got. You substituted this, right? 7. And this is 7. 2x should be equal to 7. X should be equal to 7 over 2. 3 and a half, yeah. For A, where's the equation for A? And you asked for 7, right?
And I asked for the Y value.
Okay, but see, this is the reason why. If you're subtracting 7, what should you be doing? You're not going to subtract 7 and get 0. If this is a negative 7, what do you have to do to it to get 0? Yeah, yeah. That's right. What's up?
So I found 6 for that. This one. So what am I supposed to add?
You're supposed to ask her if y is equal to 6. Which number did you ask her for? X or y?
He started with part A.
Okay, so which value did you ask for?
Y.
Y is equal to what, Kendall? 7. Okay, if y is equal to 7, you're supposed to substitute 7 in here. Where did this 2 come from? X. No, it's not 7y. Y is 7. Y is 7, so the Y goes away. Y is 7. It is 7. Cover your nose up too. Okay.
No, I'm taking away from it. Okay. Good.
Okay. But see, this is the thing, man. If you're subtracting 7 on the left, what should you be doing for it to go to 0? I guarantee you negative 7 minus 7 is not going to give you 0. So what operation do you need to be doing instead of subtracting 7?
I need to add.
Yeah, you need to do the opposite. Yeah, that's why you're getting the problem wrong. The opposite of subtracting 7 is doing what? Add it to both sides. No, Braden. Rewrite the. Look at this. Look at this. Have 2x minus 7 is equal to 14. Shouldn't you add the 7 to both sides?
Seven on the 2x and then the 14.
Look at 10 from the left and subtract 10 from the right. So yeah, what you do to one side, you have to do to the other. Okay. That's wrong. How in the world is negative 7 plus 7 14? You got about 2 minutes and 40 seconds. So, yeah, it's going to be 2x is equal to what? No, it's not equal to 0. 2x is equal to what? Markel, look, move your hand. Look, man, you just got 0 here. If you added 7 here, what do you have to do here? Yeah, you got to do the same thing. So this is 2x, 7 minus 7 is what? So 2x is equal to, what is 14? 14 what? You added 7 here, so what do you have to do here? Okay, so 14. Man, if you added 7 here, okay, it's what? 2x is equal to what? Okay, so you do that and you keep going. Now you got to solve for x. Keep going. I don't know how you got this. How would you add 7 to 2x when this is a variable? Look at what I did over here on number 2. Do you see me adding this, subtracting this 10 from 3y? They're not the same. They're not like terms, so I can't do that. The only thing I could subtract 10 from is this positive 10, and since I did it to the left side, I got to do it to the right side. Put your mask on, Camilla. Pull your mask up over your nose, please. Ava, pull your mask up over your nose, please. Okay. Okay, which one are you all on now?
B.
B? Okay, which number did you ask for?
I asked for Y.
Y is,
Negative 1.5.
okay, so Y is negative 1/2.
You have to add 1/2 to make it 0.
No, you had, but this is the thing. Move your hand. You're trying to isolate x. This is what you want to move away. I'd add 1/2 to this side and 1/2 to that side. That would leave me with negative 2x is equal to what? 0. 0. Okay. Okay. All right. Stop. All right. Get 5. Back to your. Back to your seats. Hold on just a minute. Okay, let's take a look at these. Let's take a look at these. Pick your, get your thing up off the floor for me. Okay. Now, give me A, and give me the A's out of your A, and give me your A. Okay, let's take a look at this. Because this is going to follow the suit with your homework. Follow suit with your homework. Your homework's on pages 264 through 266. And let's take a look at this so you can understand how you're doing this. Okay, now, here we are. This is what we have here. 2x minus y is equal to 14. Most of us ask for the value of y. So let's pay attention up here and see how you're supposed to do this. Each of the 0. If you have any questions, raise your hand. Most of us said y is equal to 7. And they gave us 10 and 5/10, and 7 is our coordinate. So y is equal to 7. Your equation is 2x minus y is equal to 14. That's my equation. So for my first step here, look at what I'm going to do. Look at this. This says y is equal to 7. So that means y is the same as 7, right? So do I need to keep this y in the second step, or do I just put the 7 here? You just put the 7 there. That's what some of us are confusing ourselves. Okay? Braden, what do we need to isolate, though? The what? Good. Exactly right. We're trying to isolate x here. Okay, this is here with this order of operations. We're going to work the order of operations backward. Backward. That's what we're doing. We're going backward now. This I already know is 14. But look, we don't. So that's why we're working the order of operations backwards, is because we already have a single solution for this entire site. But what we don't know is we don't know one element. We don't know what factor the 2 has to be multiplied by in order to make this true. So we're going backwards. Understand? Okay, so look at what I'm going to do. I want to work my order of operations backwards. Adding in subtraction. I'm subtracting 7 here. I want to move this -7 to the opposite side, so I'm going to do the opposite operation. The opposite of subtracting is what? Adding. I'm trying to maintain equality. I got to respect this equal sign. So what I do to the left side, I need to also do to the right side. Okay? That's what I'm doing here. Now, with that done, my second step should look like this. 2x remains the same. -7 plus 7 is what? It's just 0, so I don't need to write anything for that. It's equal to 14 plus 7 is 21. 21, good. Does everybody kind of see how I got to that point, though? Now, understand something. When you add just this one when you add just this one 7, you have added 7 to this whole side. You don't need to add 7 to this term and that term. You just add it to the left side, okay? And when you combine like terms, these two integers are alike. That's why they come to 0, okay? Because I can take, they both have the same absolute value, right? But they're moving in different directions. That's how come this comes to 0. You just combine the like terms. -7 plus 7, 1, 2, 3, 4, 5, 6, 7. That's what got us to 0. Does everybody understand that? You can't add 7 to 2x because, you know, I don't know what x is. Okay? So the 2x remains the same. And you got this other side, it's just 14. We're still trying to isolate x. What operation are you doing with the 2 and the x? So we want to move, we have to do the opposite, which is good. There you go. That's what we're going to do. We're going to divide by 2 divided by 2. An improper fraction. Remember what I told you all. I understand that the improper fraction we're going to have to convert to a mixed number. When we're doing what operation? Division. But let me ask you a question. Would it be smart to see if we can reduce first? Yeah. Can we reduce? Do 21 and 2 have any common factors? 21 is a what kind of number? Odd. And 2 is, so 2 is your only prime even number, right? So we know they don't have any common factors. So we just need to divide here, right? That's all. How many times can 2 be divided into 2? 1 time, good. And how many times can 1 be divided by 2? 0. No times at all. We're going to put our decimal point, add some placeholders here. How many times can 10 be divided by 2? 5. So here's our answer. X should be equal to 10 and 5/10. Y'all understand that better now? Okay. But that's all you were doing on this, okay? But we have to remember, order operations you always want to use. Okay, so next year when y'all are in algebra and you're solving this stuff, don't get yourself all flustered. Really, the only thing you're doing is working these problems backwards, okay? Backwards. You're no longer looking for well, let me put this back up here. You're not looking for 21 minus 7. This top down, right? Because we're trying to simplify down to one solution. No. Look, we already have the one solution here. We're trying to solve for our variable, so we go backwards now. That's all. So remember that. Okay? All right, I want you to do me a favor. Put all the lowercase cards together. Put up and make sure you've held on to where's the paper? Okay. Okay. Who has the You got the paper clip, Julian? Okay. 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 Who else didn't get a paper clip? You and Corey didn't. Who does have a paper clip? Okay. Okay. Got a paper clip. Did you get one, Brady? Let me see that. Thank you. All right, like I said, your homework is on the board here, pages 264 through 266. Does anybody have anything else that they needed me to clarify from this today? Anybody else? Okay. All right. Just make sure, just look around the floor. Make sure we get all our paper up off the floor, please. Any paper on the floor, let's get that up. Grab your paper down here, Julia, and throw it away. Yes, sir. What's up?
Is it? Like, what does it mean by we did a y?
Find y when x is equal to -3, so x needs to be -3. Find x when y is equal to 2, so you need to make y equal to 2. That's all. You're just plugging the numbers in. That's it. That's all. Y'all make sure you get all your books and stuff up, please. Let me get my scissors back here. Excuse me, turn around. Yes.
When it says Mercury X, does that mean I'm doing multiplying?
Nothing you're doing is just stick.
I'm multiplying.
Yeah. Mm-hmm. That's all. But this is wrong. They said find y. So this should be y is equal to 6 times -3 plus 8. That's not a y.
Oh, right. 2y.
Y, not 2y. It's just y. That's what I'm telling you. They tell you just to substitute for x. Find y. That's right. Y is equal to this. Okay. It means to substitute. So y you need to find when x is equal to -3. So they told you what x is. So you plug in that for x. That's all. That's it. Anybody else had a report card to turn in? Okay. All right. Cool. Ma'am. That's sad. That is not good. Only thing you're doing is substituting.
Okay, that was the word.
Y'all look here. Look up here. Okay, look at this. Find y when x is equal to -3. I'm just going to make up something here. Look up here. Y is equal to okay, they told me to find y. That means this y is going to stay the same when x is equal to -3. So this should end up being y is equal to 17 plus 3 times -3. That's what it should be. Then you solve it. The second one, find x when y is equal to 2. So for the second one, y is 2. It should end up being 2 is equal to 17 plus 3. Now, x. That's all. Everybody understand? All right. All right, gotta get ready. Get you around your desk, under your desk, and all of that other stuff. So the next class can start the way you did. Yeah, it's the same thing. Yep. Same stuff. Yeah. All right, so today is Wednesday. Third row, you can go ahead and go. Fourth row. Fifth and the first row. Jaden, grab this paper that you left over here too. And everybody else, second row, you can go. Grab that paper from under there.